Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with the leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Dr. Robert Wagner from Oak Ridge National Laboratory and winner of the SAE Medal of Honor. On today's episode, we'll discuss the outlook for sustainable energy future. We hope you enjoy this episode. Robert, welcome to the podcast.
Great. Thank you. Good to be here.
It's great to have you here, and I'll summarize this very simply. National labs are cool. The things that are developed in national labs are just awesome. They have a profound effect on society and a profound effect on the economy. One of the great things that our national labs are working on now is sustainable energy, doing a lot of really good research around sustainable energy. Robert, in your opinion, what is the long-term outlook for sustainable energy?
So one thing I should preface on the beginning is I'm a researcher. I grew up in the labs being a researcher. So that gives my perspective, and I've always dealt in knowledge discovery and then work closely with industry on how you get that to the market. But that hasn't been my primary objective in my career. So just keep that in mind as I talk about the energy transition and things. It's a little bit more from a science perspective and what I think it's going to take to get there. I always like to talk about the scale of things before I get into it, because in the U.S., we travel on road 3 trillion miles on road annually. And that's a little over 100,000 miles a second. And if you want to look at another way that I think is kind of fun is, if you go back to the 70s, Voyager 1, we launched Voyager 1, furthest object from the Earth right now, if it's man-made, moving along at 38,000 miles an hour. If you took after it right now at that kind of rate, you catch it in like 42 hours. So the scale is huge. And I want people to understand that. And also the amount of, right now we're putting out about, transportation, about 45 metric tons of CO2 every second. So when you talk about sustainable energy and what that future looks like, you're talking about a major energy transition where you're really looking at transitioning about 80% of the national energy requirements. And that's say rough numbers, about 80 quad. And I'm not sure if you or your listeners are used to thinking about quads, but as you can guess, I probably have an example of what a quad is. If you take the average home in the U.S., 2,500 square foot, not the average home, but if you take a 2,500 square foot home from the U.S. footprint, the question I like to pose is, how long do you think you could power that house on one quad? 24 million years. So anyway, I want to put this into perspective, the scale we're talking about. And the other thing that's changing is that, the world is looking at going at decarbonizing energy and looking for a more sustainable energy future. So transportation, which has historically been, I'll say liquid fuels primarily, now is going to need to work with and compete with others for electricity, hydrogen perhaps, sustainable liquid fuel. So in the transition in the future, I think it's going to take all those things. They'll all be ready at different times. They'll be applicable to different areas. Before we started, you mentioned green hydrogen and blue hydrogen, and how much it's renewable, things like that, and that's all going to be important. But I think right now we just got to get the infrastructure built. We got to get moving, and we'll sort those things out as we go. We can't wait for all green hydrogen or all decarbonized electricity. We need to be pushing everything at the same time to get there. It's probably more than you wanted.
No, this is fantastic. Now I'm going into full blown geek out with you here. So how much infrastructure is needed? Obviously, the hydrogen infrastructure is different from road infrastructure, different from liquid fuels infrastructure. It's different from renewable storage for batteries. How is the infrastructure built where in say 5 years, 6 years, 10 years, even a decade, it doesn't become obsolete as the technology has changed? Perhaps there's a breakthrough in the national lab and it's all hands on deck. We've got something special here, and you don't have to go rebuild the infrastructure all over again.
I mean, that's a really good question. But when you think about electricity and think about hydrogen and even sustainable liquid fuels, they're all just energy carriers, right? And I think there's good reason to believe that electricity will be part of our future for a long time, and not just in transportation, in buildings, industry, and all those things. The same is probably true of hydrogen, but I think they have a longer way to go in terms of the infrastructure. We have electric grid. You can argue on, is it enough, or are the sources renewable? And those are all good arguments, good discussions, are all things we're working. Hydrogen, there's not a lot of infrastructure in terms of transportation. although Department of Energy just announced several regional hydrogen hubs. This was just in the last week or two. And they're really intended to push the development of this infrastructure. So I think watch for that. I think that'll be important. The thing to keep in mind, though, is we talk about electricity and hydrogen. It's a big part of our future. It's not just ensuring we have sustainable, renewable sources. We also have to worry about storage, distribution, dispensing. So there's a lot to this. And if the buildings industry is saying, hey, we want it, and the manufacturing industry wants it as well, we need to work with them and sort out how we do this. And of course, the grid's a big part of it. Is the grid mature enough to handle this? Probably needs more build out. Storage is going to be important. I mean, if we're going to pull up, say 20 over-the-road trucks and charge them at greater than a megawatt, you have to have some storage, on site there. You're not just going to hook that to the grid and pull off. And it could be short duration storage. We talk a lot about long duration, but what about short duration storage? And on this theme of sort of a sustainable energy future, how do you move renewable energy around the world in a big way? Years ago, I read this interesting article where I think it was Germany was talking about how do we ship and get nation months of renewable energy stored. And so it's an interesting conversation to have because some parts of the world may not be able to be renewable 100% based on how we think of it today and what our technologies are of today.
Short duration storage, how is that achieved? Is that through battery technology? Is that through some of the cement breakthroughs? Is that liquid fuel storage? What does that look like from a technical perspective?
In the simplest terms, I think of like flywheels. Yeah, that'd be a real simple thing to think about. Say you have some, and this is just Robert's thought on this. Say you have some truck stop and you're going to charge at megawatt plus. You spin up a flywheel, you're able to charge fast, and then you spin it back up for the next. And again, not advocating that's a solution, but just an example of what short duration storage might look like.
So is it fair to say that the transition to sustainable energy is going to be a multi-prong approach where certain solutions work for, say, Class 8 vehicles, where home storage or grid storage, there'll be different types of approaches to sustainable energy depending on the use case?
Yeah, yes, absolutely. I think it's going to take everything, and there's definitely going to be better fits for different things. And we're kind of seeing this already. And if you look at, there was a national blueprint put out for transportation. And I'm not sure if you've seen it, but it's worth Googling if you haven't. It was put out by DOE, DOT, HUD, and EPA. So they put out this national blueprint, which is sort of a vision of what the future might look like. And it has electricity, hydrogen, sustainable liquid fuels in different sectors. And it even kind of shows that. It's trying to give an outlook of what's near term, mid-term, and longer term. And it shows it's going to take a bit of everything as we move forward. One of the challenges comes, though, is where do you invest now? Some things are harder than others, and so some tough decisions are made on how they invest.
For our listeners, how would you classify sustainable liquid fuels? Is that renewable diesel, or how would you classify that or explain it?
Actually, that's a really good question. Anything you can do to make it sustainable in terms of renewable, and would it be, if it's classic, sort of what we think of as renewable diesel, where you could drop in? I mean, that's perfect because ideally it can just go in and there's not much change needed. But for other renewables, and let me give you an example of, say, ethanol. When I was earlier in my career, I helped lead a big Department of Energy initiative called the Co-Optimization of Fuels and Engines. And we stood this up in 2014. NREL, National Renewable Energy Lab, John Farrell was the lead for us at that time and helped us stand it up. And we were talking about 30% displacement of liquid fuels with something like ethanol or some other, I'll say, renewable or sustainable fuel. And that was a huge challenge. And now we're talking about 100%. So the challenge is even bigger. So there's a lot of different ways to do this, a lot of different types of feedstocks. And we might need to get into fuels that we're not used to using in mass quantity. So say something like a methanol.
What do you see the biggest challenge facing the transition to sustainable energy today, especially looking at a low carbon future? Is it technology? Is it regulatory? Is it consumer adoption?
I think it's all those things, and it's time. These things will take time. No matter how aggressive we are on the spending, there's so many pieces of this that have to move together. And you said it well, the consumer acceptance. We have to have a pull as much as a push, and I think we can get there. it will take time to get all this moving. What's exciting to me now, though, is a lot of companies they're really on board. They're pushing these technologies. They're making big dollar decisions on what they push. The government's making big investments, trying to drive the research, drive the infrastructure. The Department of Energy, or I'm sorry, the Department of Transportation even has what they call ARPA-I now, which is focused on infrastructure. So it's just going to take all these things happening at the same time, and it's not going to happen overnight.
The consumers, they have to buy in. And I use the word, they have to believe. They have to be a part of it. They have to see the positive benefit. I could see things, I've talked to friends perhaps, that on the sticker when you buy the vehicle, if this vehicle reduces carbon emissions by X and you've planted X amount of trees, this is really great. This empowers them and they feel good about the purchase they're making. And getting into automotive, history always has a funny way of repeating itself. I forget the Mark Twain quote there, so I don't want to misquote Mark Twain, but sometimes it rhymes. And the early automotive design went through a period of diversified powertrain propulsion options, and today we're seeing a large shift towards battery electric. We're seeing a rise in hybrid sales. Does history repeat itself or rhyme where the consumer's saying, okay, these are my low carbon options, not necessarily all battery electric, but there are different options, and they kind of just gravitate which one works best for their family and for their needs?
I think so. I think like for myself, we do a lot of traveling, across multiple states, and right now we haven't bought an electric vehicle yet for that reason, but it's very high on our list. And I'll tell you, with all the new offerings and what's happened with the range in recent years, it's starting to become practical, I think, for people who have a family situation like I do, where we're scattered and we have to travel a lot. So I think, again, it took time, but I think we're to a point where we're starting to get good market penetration, and the pull is because it's going to be a fun to drive vehicle and it meets my needs and it can do what I need on a day to day. Now, everybody that may not be for them, and I think that's fine. It's just going to take time.
The thing about, and I own an EV, and I'm a proud EV owner that's not discussed enough, is the convenience factor. You come home, the vehicle goes to sleep, you go and make dinner for the family, and you charge it, and it's sleeping, and when you got to take the kids to school the next day, it's charged. You don't have to go to a gas station. To me, that's a huge convenience factor that's not discussed now. That's on the consumer personal side. And then on the commercial side, over 300 billion miles a year traveled by commercial vehicles in the United States. There's a lot of economic reports. Well, we can't go battery electric. We're not going to get the range because of the weight issues there. Does hydrogen become, do you think, in your opinion, the dominant renewable energy for the commercial trucks? Or is there a new technology that's emerging that could eventually replace battery electric or hydrogen for those long-haul commercial trucks, especially Class 8?
I think if we get the infrastructure in place, it's certainly part of it. It's, we have these very aggressive goals going out to 2050, it's a long time off, but there's a lot of infrastructure to change. I think for hydrogen and I think the biggest application I'll say right now, or near term, I shouldn't say right now, but near term, is for those cases where it comes home at night. And so you have a consistent fueling place. As it builds out, the network builds out across the US, that'll change. But right now, you have to have places to fuel. And we don't have that at the moment, not with enough quantity. Where electrification, if you look how that is built out, heavy truck and things like that, we don't have the charging stations we need yet. But look what happened in light duty in the last few years. It is really coming on strong. And I have to think they will sort it out, and that'll continue to be built out. But if I can add one more thing, too, we also have just an incredible liquid fuel infrastructure out there. If you look at all the stations around the country. So the other question on that would be, if we do go to, say, a different type of liquid fuel, and maybe it's methanol or something like DME or what have you, how do we deal with the compatibility of the fleet and the compatibility of stations? Is that something we could retrofit to? So I think we think about all these things, and they're going to have different timelines.
Then does renewable diesel become kind of, we want to call it, as a friend of mine in the industry call it, a bridge fuel to help us get towards there? It becomes a bridge or a stepping stone? I'm
not sure if it's truly renewable and it's truly net zero. I think it could be as much as part of the future as the bridge to that future.
That's a very honest answer, and that's probably the best answer I ever heard on that, because there's been a lot of debate around that. I have friends that own large shipping companies, and they're trying to get by as much renewable diesel as they can. And then there's other friends on the other side say, no, that's not as good as battery electric. So I really appreciate your honest answer there. Is infrastructure the key to achieving the 2050 goals? Is that the thing that has to be built up the most in order to achieve the global net zero 2050 goals?
Yeah, I think so. I would agree with that statement because there's just a lot to do. I mean, pick all the energy carriers we're talking about, the sustainable liquid fuels we've talked about. We do have a major infrastructure, probably not compatible. Maybe it is if it's completely renewable and it's a drop in, but let's assume it's not. So what would you do to make it compatible? Electrification, massive grid system. It's going to need some things, especially if we're depending on renewables that are intermittent. So we're talking again, as we started with not just the sources, but the storage, the distribution, the dispensing. And then probably the least mature of them at the moment is, as far as widespread use, I should say, is hydrogen. So, all these, there's a lot of different pieces to this.
There's a lot of different pieces. Is that do we have the pieces, the well-known pieces? We have the battery electric technology, with the hydrogen technology, with the renewable diesel technology, and we have microgrids that are now starting to pop up around the globe to help reduce the carbon output. Overall, though, do we have the technology that's needed today to achieve the 2050 goals, or do we have to invent new stuff? Companies have to commercialize stuff, or where do we stand from a technological standpoint?
There's actually an interesting I think it's actually a roadmap put out by IEA that talked about 2050 and state of technology. And I mostly agree with it, where they said about 50% of the technologies we need they're in the market and they're being used. And the other 50% are under development. So think of they're in prototype stages. But I would probably add that a lot of the technologies that I wouldn't say a lot, but some portion of the technologies we need we haven't even thought of them yet. Or they're in very, very early development stages where we haven't made all the connections. I mean, 2050, we're almost 30 years from now. And it's a short time when you think about all the infrastructure we need to build, but it's a long time than what can happen to technology. I'll give you one quick example. The iPhone came out in 2007, and look how it's changed our lives. 2005, I couldn't have imagined an iPhone. I joked to my friends on that, like ChatGPT last November, I read this article and I was like, what is this? So I looked at it online and couldn't believe it. And now it's evolved even more. That was just November. So what other things are going to happen between now and 2050? So again, I went off on a tangent a bit there, but I think there's some technologies that will be part of it that we know, but I think there's a lot of unknowns and a lot of things being developed.
A lot of technology is going to change. It's going to be fascinating to watch from the sidelines. An engineer or somebody's going to have a major technological breakthrough that could go on to potentially change the energy landscape. On that theme, are there any new energy technologies bubbling up in the labs or research papers that you've read that have really piqued your interest and said, okay, there's something here, something's cooking?
So the things that there's of course lots going on in the labs, going on in industry in terms of better battery technologies, hydrogen storage, better utilization of these things. But I'll tell you, the things that get me the most excited to think about is the impact of, say, AI on these things going in the future in these systems, the impact of quantum computing. What might quantum computing really look like in quantum security and quantum sensing and things like that? These are the things that I look back in history on, just like where computing has gotten us, over the last, 70 years, say. Well, where will quantum take us? So it's a big unknown, but those are the things I think about to get me pretty exciting. If I can tell you a little bit, I have some thoughts on computing I thought I'd share to kind of put this in context, is if you go back to the 50s, computing was electromechanical systems. And in the 80s, 15-year-old me was mowing yards and buying an Apple IIe. Late 90s, a teraflop was $50-something million. And about, within the last decade, you could buy a couple teraflop machine that's liquid cooled, you put in your car. And now we're at exaflop systems. And exaflop, so Oak Ridge has the world's fastest computer. I gotta give props to that, although someone will surpass us. And we're always just pushing. Exaflop, a billion calculations a second. And to put that in context, the universe is about a billion seconds old. So if you did a calculation every second for the age of the universe, that's how much an exaflop system does in a second. So, I mean, technology has really moved. And so when I think about even the future of regular computing, I'll say binary computing, future of quantum computing, and all these things and what they're going to do in the development of new technologies that are going to be, commonplace one day. I mean, that's what gets me excited, thinking about those. I don't know if you read anything on recent Nobel Prize in physics was for attosecond. Basically, they're able to pulse light at attosecond levels, which means you can start looking inside atoms and looking at things that are going on with molecules. That's an amazing thing, and where that could lead towards sensing and development of quantum systems and stuff like that. Maybe more than you wanted.
No, but it's great. But you think about the impact that breakthrough is going to have, especially as it gets commercialized. On the AI front and the impact that AI will have, do you see increasing energy? Because right now, I can see AI where demand spikes, where the AI can predict a demand spike in certain areas, and the grid can have the excess capacity to handle that, and from a prediction standpoint, to handle all that, and then to reroute energy sources automatically. Do you see it from an AI in the, let's call it the early days of AI for energy, increasing the efficiency of the energy grid and the energy network that we have today?
Yeah, that's one application I could say. I could see the potential of doing things like that, or managing complex systems of vehicles and mobility systems. So think about, controlling these complex systems. But I also think about it at the very fundamental level too. So say you're trying to do some very fundamental modeling from direct numerical stimulation, and you want to take these very fundamental things that are very computational intensive, and you want to use them in engineering codes. There's a lot you can do around AI to bridge these things as well. So it's at all scales. And what's enabled it has really been the speed of computers. So I'm very much a statistics person. So when I did my PhD, it wasn't in statistics, but I took a lot of statistics I enjoy it. I'm a numbers person. And what limited us back then was compute power. And now we have it. So I tend to think about AI as it's a lot of statistics with a lot of power. Now, some might want to argue with me, but because they certainly have developed new methods and some really clever things, but computing has enabled a lot of that.
Computing's special. You think about the impact computing has had on society. Imagine if we didn't have computers, where we'd be today. It'd be a whole different world, and it's going to be exciting to see where quantum goes as well.
There's so many examples like that, and I tend to, when I gave that Buckendale presentation, I referred to these things as disruptive surprises, because even the internet, 30 years ago when I was a student, the internet as we know it was not a thing to the common person like myself. It just was not there. GPS was not there. GPS came to be from JPL in the early 60s when Sputnik's up there, and they're like, the engineers are noticing that there's a frequency change and a signal off of it, and use the Doppler effect. And, there's a lot of things that happened after that, but now we have GPS and it's on my phone. So all these really interesting breakthroughs that really weren't intended for, say, our industry, the transportation industry, we're just reaping huge benefit from it. So what's next? And that's where I think quantum, AI, new manufacturing methods. Think about if you were to design an engine right now where you didn't have to worry about the constraints of casting. It might be a very different approach. The fundamentals of material development. I mentioned that recent Nobel Prize with attoseconds, which is going to enable some attosecond physics. So imagine now you're starting to look at materials at an atomistic level with a lot more precision, and perhaps able to design things differently. And again, this is just me speculating, but the things that get me excited.
Because designs of the vehicles are going to change. Design of potentially rail will change. Design of maritime will change when we have all these breakthroughs. And I've been on the big kick for a while. It's going to increase efficiency. Perhaps there's a better design with less drag that uses less energy that makes it more efficient, and that's special. We haven't touched on maritime yet, but there is a lot of movement globally to decarbonize maritime. What are your thoughts on maritime as it relates to decarbonizing maritime and using sustainable energy in maritime?
I think maritime's interesting because just in the nature of some of these big vessels, and there's a lot of stories out there where they have some out there running on ammonia now. They're of course looking at hydrogen, so they're looking at a lot of different, say hydrogen or hydrogen dense type fuels. And it's an area I think there's a lot of opportunity. The one concern that I think people will have is, let's say I have a vessel out there that's running on methanol. Will I be able to get that fuel in the port, in all the ports that I need to get that fuel? So there's those kind of considerations as well.
Do you feel that maritime is a competitive advantage since at the ports at some ports, I repeat, not all ports, but some ports have the land to put in the fueling infrastructure, and a lot of these vessels run on fixed routes. Perhaps let's just use New York to Liverpool, Port of Miami to Liverpool, for example. So they're going on consistent fixed routes where you only have to have the infrastructure at one place. Where a commercial vehicle, let's say you're going to visit your parents or I'm going to visit my in-laws, we're going to different destinations all the time. Nobody's particularly going the same way. Does that give maritime let's call it a competitive advantage, since those are fixed routes and the infrastructure is there, the room is there? And then from a policy standpoint, the facilities are zoned for that type of infrastructure as well?
It's a good question. I have to be honest. I don't have a good answer for it. On the surface, it sounds like it would be, but I don't feel I understand all the economics and all the things that feed that.
There goes the statistics for you.
You had mentioned continuing to improve energy efficiency and all those things, which I think is really, really important. Sometimes it gets lost in the discussion. When you factor, like in the U.S., we reject 2/3 of the energy that we produce and we don't use it. About 1/3 of it's used. If you go look at, there's some energy diagrams that come out of Lawrence Livermore every year that are really interesting from that standpoint. So there's sort of three parts. There's that part. The other part we talked about, you have to transition about 80% of your energy supply and distribution, dispensing, storage, all those things. But then the other part that we can't forget about is whatever technologies we put out there in mass, it has to be sustainable as well. So that's either with readily available renewable resources, or we're getting into this very circular economy of reuse, repurpose, things like that. And I don't think we can lose track of that. That's you can come up with great technologies, but if we don't have the resource to build it out to scale, it's not going to get there. Now, that doesn't mean that you couldn't have a lot of different technologies bringing what they can to the challenge. And I certainly would not say, well, let's not pursue electrification because this one approach is not going to fully scale. We're going to take steps to get to where we need to be, but we can't lose sight of that things have to be sustainable even on the resource front.
We'll get into that in a minute. I'm curious, though, why do we reject 2/3 of the energy?
From a thermodynamic standpoint, the parts that I would be used to thinking about is very low quality, low temperature, not much you can do with it. It's rejected heat. I'm sure there's many other pieces to that, but that's from being sort of a thermodynamics background, that's what I think about.
Okay, so this is a broad national laboratory question. Is there a colleague of yours in a national laboratory that's studying this and trying to figure out how to capture some of that energy that is rejected?
That's important to a lot of research going on. There was also something the Department of Energy years ago put on what they called these big ideas summits, and there was one idea to discuss, and that one's called HEATER. I can't remember what the acronym stood for. It was very much about that, or that was a big part of it, is trying to better utilize low-grade heat. And I know in the buildings areas, they certainly look at those things. I would say probably across manufacturing, everybody's always looking at that. How can we make better use of this low-grade heat?
As we introduce these new sustainable technology, how can we make sure that there's a sustainable resource where if somebody goes all in on this, that there's I don't know, let's use a warehouse terminology. There's plenty of backlog in there. There's plenty of freight, plenty of boxes. Don't worry, we're not going to run out of Cheerios today. But for energy, how is that modeled out, or how is that done?
I think that's modeled a lot of different ways. And it's always a concern when we're talking about new technologies is that, if I like how you kind of put it, if everybody says, all right, we're all in and we're going, is there enough resource to do it? And what's the price of that resource, not just in dollars, but in what's going on in certain countries, whether it's social things or local economic things? How do we sort of balance all that? And it's a good question. I don't think there's a silver bullet to it either, but we have to think about it.
We have to think about it. And the one thing, this is my personal opinion, that we have to think about, and we can look at history, we have to understand the geopolitical or the potential geopolitical implications of going in on certain technologies. And it just seems that we learn these lessons over and over again. As society shifts to a more sustainable, low-carbon mobility future, in the deployment of new technologies, what role will the national laboratories play in enabling this future? Will you be our cheerleaders? Will you be our developers? Will you be our engineers? What role will the national laboratories play?
I think what we bring to it is sort of what we've always brought to it is the national labs. I'll think about Oak Ridge, but then I can give you many examples from other labs. Is we steward very large science resources that like no other place can really steward. Like industry wouldn't steward an exascale computer. They wouldn't steward, massive neutron sources that are used for fundamental materials discovery, things like that. So the labs are really good at stewarding these big resources and then working closely with industry and academia and even other national laboratories to bridge that science to application. And to me, that's been the really exciting thing for me having a career is I came to Oak Ridge as a mechanical engineer, and I was doing engine combustion work. And within a couple of years, Oak Ridge turned on what they call the spallation neutron source, which is the world's most powerful pulse neutron source. So I had a friend over there, and I thought, boy, I'd like to image a diesel particulate filter. Could I do that with neutrons? And turns out you can, although we did it on what they call the high flux isotope reactor. And anyway, so there's these big tools that help you get to some of the fundamentals and then the application. The supercomputers too, I've had a lot of great opportunity to help set up collaborations with industry and the supercomputers. So it's really neat to bring these big science tools to bear. The other thing I will say, I think the labs are poised pretty well too. The thing nice about the labs too, that there's all this expertise, there's all these facilities, and we're really poised to help in times of national emergency. The pandemic was a recent example where the 17 labs formed a collaboration. They worked with others, and they accelerated our knowledge of the virus and what a vaccine will look like. Accelerated manufacturing of masks and ventilators. So, the labs played that kind of role. I mean, right now, my division, there is many formal collaborations with industry where we're bringing our expertise and they're bringing their expertise, and we work hand in hand.
So basically, you're acting as I don't want to say as a mediator, but you're bringing individuals together to have open, honest discussions about the future of sustainable energy and what is it going to look like, and kind of how do we do this together, collaborate together potentially? Yeah,
and then how do we answer some of the fundamental needs that they have that they need help solving? I've also viewed us as an unbiased source of data for decision making. Again, on my background, where I spent my time in combustion and looking at a lot of different, unconventional combustion approaches in engines, and there was a lot of discussion out there on what does that really look like, what's the potential of that, and so a lot of my work focused on trying to take these fundamental, breakthroughs in combustion and put them in production viable hardware, and trying to put that information out in the literature on, hey, here's what it really looks like. When you have all the concerns and constraints of something that potentially could go out in the real world.
So, how this experience of working in a national laboratory, interacting with industry, what technologies think will be commonplace in transportation 25 years from now, 2.5 decades?
Well, I would say I think electrification is going to play a major role. I do think we'll see sustainable liquid fuels in some form. I don't know if that will be more in the commercial vehicle sector, marine, locomotive, things like that. I think we'll still see it, but I think electrification will continue to grow. I think it's all part of our future. Now, what the other part I think is going to be really exciting too is to think about what will the computing, sensing, controls, management of these complex systems, what will that all look like? Connected and autonomous vehicles, I think that will continue to grow. I don't know what it'll look like in, say, 20 years from now, but it's certainly been very aggressive. It started out, I think, with a lot more optimism than, and then it kind of reality set in. But now, boy, a lot has happened in the last, say, decade in that area. I tend to think of everything like the Gartner hype curves. I don't know if you've ever looked at the Gartner hype curve.
Yes.
And I love them because I actually wish they didn't have the word hype in them, because I think it's got a negative connotation to it, which it's not. It's like, okay, we get really excited, and you have that peak of inflated expectations, and then the trough of delusionment, and then you start climbing out. You start saying, okay, all right, here's where we really are. Now let's see what's going to happen. And I think some of the greatest technologies we've had all started that way, right? You get super excited, put a lot of effort into it, and you find, okay, this is really hard. What can we do? And then you end up doing great things. I'm an optimist, if you can't tell.
You have to be an optimist.
Yeah.
You have to be the cheerleader for society. I mean, that's how I look at it. You have to cheer what's the best for society. You mentioned rail. I had a long talk with a Wharton professor of rail a couple months ago about the friction on the tracks and how that plays into the energy use. It was really, really interesting. Do we start to see more sustainable energy? You mentioned sustainable liquid fuels go into rail. We're seeing stuff being developed, technology around battery for the locomotives. Do you see that? We talked about maritime. We talked about ground vehicles, commercial vehicles. Do you also see rail being a big target for increasing the sustainability of rail?
Yeah, I think it all has to be. I think everything does. If we're truly going to get to a net zero future, and I know the vision is by 2050, and can't wait to see how everything develops because I think it's going to be exciting. But we have to consider everything. And again, I think there's going to be technologies out there that we don't quite fully understand or have thought of yet. I'll give you something exciting that I think is going to be important at some point is wireless charging. And you can argue whether it's going to be important for stationary or dynamic when you're driving down the road, but I think it's going to play a role. You're talking, you had an electric vehicle, you come home in the evenings, you plug it in, you go have dinner. It'd be great not to even think about it. You just roll in and it just charges itself. And, they're to the point now where they're starting to put, a couple hundred kilowatts across, 6-7 inch gap at high efficiency, as high as you plug it into the wall. So, and I feel like we're at the early days still. So where is that going to really end up? I think all these kind of technologies that are being looked at and they're, just continuing to push, they're all going to settle out somewhere that's going to, I think, change how we do things.
Change how you do things. Wireless power is interesting. There's a lot of talk of putting it on freeways or interstates, but what if you put it in parking lots? If you're at a Target or a Walmart, or you have it in at a driveway at a home, so you're visiting your friend, and perhaps you go to the friend's house for dinner, and your vehicle is charging when you're not even thinking about it. One, it's more cost effective because the homeowner will take care of that, and then the retail establishment will pay for that because they want you to shop in their store. That wireless becomes a really interesting, let's call it an economic incentive to shop in my store versus the other store. And that could change consumer behavior. Then consumers become part of it. And then the whole debate around range anxiety, and then you have charge anxiety. That all goes away. What we do know, it's going to be a lot of fun to watch how these new sustainable energy technologies are developed, deployed, and commercialized. In your opinion, Robert, what does the future of energy look like?
To me, and for transportation anyway, and let me focus more on commercials, a different animal. So just me and you driving our car every day. I could envision a day where we don't even know when we're fueling it. It's just fueled. Years ago we proposed something along this line we call extreme range, where maybe you only fuel at the equivalent of what you would for an oil change nowadays. But I can imagine a future where it's just always being refueled. Whether it's wirelessly or however it's doing that, it's also scavenging, and we're not even thinking about that. I mean, you talk about plugging in every night. Again, if you had wireless, would you ever know when you refueled it for sure?
Nope.
You just drive it. You just make the most of it.
And then if I never had to think about refueling, I would never consider getting rid of an electric car because you have to think about going to a gas station. I have to plan for this nonsense. Oh, no. And then the consumers won.
And people could plug holes in that because, okay, I'm going to go on a trip. What's that look like? So that would be a different situation. But I don't know. I'm optimistic that it's going to be a really interesting fuel. Now, commercial vehicles, different animal. Those things are up 95% plus of the time. They've got to be up. There's no two ways about it. It's just going to be different.
It's going to be different. It's going to be exciting. It's as we said it in this conversation, there's not a one size fits all to the future of sustainable energy. There's going to be a multi-pronged approach, or if you want to use the flywheel term there, it's going to happen. Sustainable energy is going to scale, and it is the future. Robert, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Yeah, probably the takeaway from my career, I've had a fun career at the National Labs. And with SAE, SAE's been sort of my forum to meet people. And, my takeaway would be that nothing's impossible. If you have a strong and passionate team from diverse fields, it's amazing what you can do. Now, people say, yeah, but it takes money, it takes this, takes that. Of course it does. But in terms of technology and where we will be, we shouldn't limit ourselves. We will get there.
Nothing is impossible. Be a cheerleader. Be like Robert. Nothing is impossible. Today is tomorrow. Tomorrow is today. The future is sustainable energy. Robert, thank you so much for coming on SAE Tomorrow Today.
Great. Thank you.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we hear how Cumberland Additive is leading the growth of additive manufacturing in Pittsburgh.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.